So now in recent videos we looked at switching my LED modules here. They're a higher wattage LED and they are pretty bright, as you can see right there. We've been switching them with transistors. So when it comes to switching these modules with the 2N2222 transistor, because the 2N3904 can't handle as much current as one of these can provide, and so we're using a transistor 2N2222 that can handle more current. I did not want to switch the two of them though, LED modules, with just one 2N2222. So we looked at using a higher wattage transistor to switch it, and that's all it is, a higher wattage transistor to switch two of them. In this video we're going to look at putting the 2N2222 in parallel, a couple of them. So we named them Q1 and Q2. That's something I don't normally do in my videos, but a lot of times you'll see each transistor with a Q label. That way when you read like the description of the circuit, they say Q1, you know they're talking about that transistor, or Q2, they're talking about that transistor. Not vital for this one because they're both doing the same thing in here. So we close the switch and we have just one base resistor for this circuit. I'm going to use 330 ohms. At higher currents, their gain goes way down. And so we're just going to give quite a bit of base to emitter current. Now we have a problem. So we got the two LED modules there. So they have their own protective resistor for each of their LEDs. And so they're just going to pass current as close to 5 volts across it as possible, whatever the transistors. And then we got the ballasting resistors, whatever voltage it allows to make to the LED modules. So those currents are going to come back together though, and then they're going to be distributed among the transistors. And we have a problem where without these ballasting resistors, if one of the transistors starts getting warmer than the other one, it's going to start conducting better, that base to emitter and collector to emitter current. And that's the way they go. They get warmer, they start conducting better, and that makes them get even warmer and they start conducting even better. So you have a problem. Maybe one's going to conduct so good, the other one's not really conducting much, and one might overheat. So probably not with this load, but it's a possibility with a load that can reach its maximum current. So these can handle 600 milliamps of current, and the power supply will show that this whole circuit's only going to get about 400 milliamps of current. But still, 400 milliamps of current is a lot for just one transistor. So we got the two of them in parallel. That's the main takeaway. So some of the base current is going to go through one, or it should be half the base current will go through one transistor, and then the other half of the base current will go through the other. And these two resistors will help make sure that if one of the transistor tries to start conducting better, it takes some of that voltage off of it, and so dissipates some more of that power and evens things out. And now we make it over to the circuit. So you can see here, that's going to be where we put our load. We have the collectors on top, and they are connected directly together right there. They even out the current that flows through them. We're not separating it ahead of time. We have our base resistor there. Our bases are connected together. Again, these ballasting resistors will even out the current in the long run. And then we have the positive supply there. When I press the button, that turns the transistors on, because we're getting a little bit of current there headed to ground. And there you can see the ballasting resistor. So each transistor has its own ballasting resistor. That's important for this. They're not sharing a ballasting resistor. And we will now attach the module. So this is one with the shorter wires, and I tried to make them the same length. I didn't try real hard, but it works out that one has longer wires than the other. So I had to solder the wires on. Talked about that in earlier videos, not going to go into great detail on that. So this one overlooks that one a bit, and so we can get a lot more light in one area. And we'll zoom back and grab the power supply here so that we can see the currents that are flowing through. And you're going to see now that we got about 400 milliamps of current. Now when things warm up, you're going to see that the current goes up. As I said, as these transistors get warmer, they start conducting better. So you have a problem if one of them starts conducting more than the other one, it's going to get even hotter quicker and take over how much current's going through it. And the other one won't get as hot, it won't conduct as well, and you could overheat a transistor. So as we said before, the ballasting resistors, they prevent that from happening by keeping the currents between the two of them the same, because there's some more resistance on the emitter side. So, in any case, that's it for this video. Hope you enjoyed. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.